Okay, so this 6 factorial is exactly what we have there. Now again, this actually has a value. That value is 720. Again, I don't expect you to memorize these at all. There's a factorial button on your calculator. You can use whatever you want to do this. 4 factorial, 4 times 3 times 2 times 1. So 4 times 3 is 12, times 2 is 24. Now, this here, 3 factorial times 2 factorial, does not equal to 6 factorial. Don't bother writing that down because I'm about to erase it. It's not 6 factorial because what this is equal to is 3 times 2 times 1 times 2 times 1. As I said earlier, the factorial notation, that an exclamation point, it's in that same category as exponents. And when we talk about our BEDMAS rule, do your brackets first, do your exponents next. Well, exponents includes this factorial notation. So what we have is 6 times 2, so this works out to be 12. Okay, so just be careful. Don't collapse them and then take the factorial, because 12 is significantly smaller than 720. 6 factorial can be written in different ways. We've already talked about this one. We can just write it all out. I could also write it as 6 times 5 factorial. Because 5 factorial is 5 times 3 times 2 times 5, etc. 5 times 4 times 3 times 2 times 1. I can also write this as just expand it 6 times 5. Okay. And I'm just going to write the rest of it as 4 factorial. And we continue that trend on, 6 times 5 times 4 times 3 factorial, or 6 times 5 times 4 times 3 times 2 factorial. Why do we do that? Well, sometimes it's going to be nice to be able to cross stuff off. If I take your calculator weight, or I use numbers that are too big for your calculator to deal with, which is around 69 factorial on these calculators, you have to be able to reduce them without the use of a calculator. So by definition, n factorial, any number factorial, not any number factorial, any number that we're going to be using, is that number times 1 less than itself, times 2 less than itself, times 3 less than itself, and so forth and so on, until we run eventually to 3 times 2 times 1. So 100 factorial would be 100 times 99 times 98, and we would continue that on until we got to 3, 2, and 1. What we have to do here is, though, we have to define this. If I gave you something like 99.5 factorial, and I kept subtracting 1 from that every time, I'm never going to hit 1. I'm going to go from 0.5 to negative 0.5. So the factorial notation that we work with is only dealing with whole numbers. Okay? No rationals, no integers, etc. Okay? Now, since we're dealing with whole numbers, we have to talk about what the heck is 0 factorial. So when we talk about this notation, okay, in one argument it could be 0, because 0 times anything is 0. But there's some notation that we're going to work with later on that's going to work out like this. And if we say 0 factorial is equal to 0, 7 divided by 0 is undefined. Okay? So for the purposes of our work in high school, because I've heard a little bit about other notations, not just whole numbers, we're going to say 0 defined will be defined to be 1. Okay, so 0 factorial, we substitute in 1. Okay. And again, that has to do with some notation that we'll be talking about later on. Why doesn't my thing look that bad? Okay, so I can write 12 factorial as 12 times 11 times my 10 factorial. That 10 factorial would be that 10 times 9 times 8 all the way down to 1, but I'm just abbreviating. 8 factorial is 8 times 7 times what thing would go here? 6. Just 6? Has to be 6 factorial, yes. Okay. Now this is useful, again, this idea of reducing before we grab our calculator. Okay, so 10 factorial is 10 times 9 times 8 times, now I stopped at 7 factorial. Why would I stop at 7 factorial?
Or because the number includes 7.
7 factorial divided by 7 factorial is 1. So that just leaves me with 10 times 9 times 8, which can be quickly determined to be 720. Now you guys that have the 83s and the 84s, you have an extra 20 digits from when I got through high school. One of the problems that we do a lot in high school is going to be 52 factorial over 50 factorial. Well, when I was in high school, my calculator went, yeah, that isn't happening. I don't have enough memory. So I have to do it this way. I'm going to give you problems that are going to be like 72 factorial over 70 factorial because your calculator doesn't have enough memory to do that. Some of them do, I think. That one might have some significant more memory on it. The 83 plus, yeah, those two I think have more memory, but I know just the 84 and the 83, they stopped at 69 factorial. So without technology, what is 20 factorial over 18 factorial? 20 factorial is a huge number. 10 factorial is already at 1 million. So these are two huge numbers over each other. Well, the easiest way to do this, 20 times 19 times 18. Oh, look, I can cross those off. Now 20 times 19 is 380. You look puzzled. Did I do something wrong? Because I could have.
No, I did something.
And again, as I said, this one here was the one in high school that I couldn't use my calculator for. Because it wouldn't give me 52 factorial. It was just too big of a number. Your calculator will give it to you, but it's going to be some 1 point something times 10 to the 24 or 25. I don't know exactly what the number is. But again, expand the largest number until some point as I can cancel something off. So 52 times 51, I believe, is 2,625, but if someone could quickly check that. 2,650. What's that? Okay. Now in this case here, same basic idea. I'm going to expand the larger one, which is my 8. 8 times 7 times 5 times 6 times 5 factorial over my 5 factorial. And then what am I going to cancel out? What am I going to do with 3 factorial? 3 times 2 times 1. So that's going to cross off with that guy. 3 times 2 times 1 is 6. My 5 factorials will reduce down to 1. All I'm left with is 8 times 7, which is 56. So I want you to take a second and see if you can write. This is the reduced form. What did I start with? So this is the reduced form. What did I start with here? So what do we get for 6 times 5 times 4? What would you write that as a quotient of these factorials? Okay. You can see that we probably crossed off 3 factorials have reduced. So this is going to be equal to 6 factorial over 3 factorial. Here, the next in here would be 11 factorial over 11 factorial. So my top is going to be 15 factorial over 11 factorial. Now, what's most commonly going to happen here is we're going to work with, not with numbers per se, but with expression. Okay. So n factorial can be expanded to be equal to n times 1 less than the self times 2 less than the self, which we're just going to write as n minus 1 factorial. Okay, so now for the next guy here, we have n plus 2 factorial. We're going to have n plus 2 times, what's 1 less than n plus 2?
N plus 1.
What's 1 less than n plus 1?
N.
N. Okay. There's my expansion of n plus 2. Now here, what is this expansion? What is this the expansion of? A number times 1 less than itself, times 2 less than itself, times so on and so forth. So the number here is n minus 4, and then the factorial, because that's what we see. We have 1 less. Sorry, the number times 1 less than itself, times 2 less than itself, continues on. This is where we're going to start to get into some of the more complex ones. Here we have, there we're writing. When you have these guys here, and you want to reduce it down, we want to get rid of that factorial notation. We can't really work with the factorial. We don't have a way to solve if there's still a factorial around. So if I want to reduce this, what's the larger number? N plus 2 factorial or n factorial? The n plus 2 is going to be larger. So I'm going to expand the n plus 2. N plus 2 n plus 1. Hey, there's my n. I'm just going to, I now can cross off my n factorials. So I expanded the larger number, crosses off. My answer is n plus 2 times n plus 1. I'm perfectly satisfied with that answer. I might, in some cases, ask you to expand it into that notation. So all I've done is my distributive property there. What's bigger, n minus 2 or n minus 2 factorial or n minus 1 factorial? My denominator happens to be bigger in this case, so I'm going to expand it. N minus 2 factorial, n minus 1 times 1 less than that, which would be n minus 2. Okay, I can stop at that point. N minus 2 factorial divided by itself is equal to 1. My answer is not n minus 1. My answer is 1 over n minus 1. And because the top reduces to 1, the bottom reduces to n minus 1. Now here, what's bigger, n factorial, a number factorial, or a number? What's bigger? The factorial. The only exceptions are 1 factorial and 2 factorial. Everything else is bigger. So I'm going to expand my top, n times 1 less than n times 2 less than n. And I'm going to stop there because now I should notice that my denominator is going to be able to reduce with part of my numerator, and this guy reduces down to that. Any questions so far? Now this is a level of excellence question. I don't know the level of excellence. It's a difficult question where you're asked to solve an equation that has factorial in it. There is no way for me to solve this one without trial and error if I leave the factorial notation there. But we've already figured out how to get rid of that factorial notation. We're going to expand the larger guy, which is n. We have n minus 1, n minus 2. There's my factorial. So I'm able to cross that off, leaving me with that. How do we solve that? Well, we have to recognize that this is a second degree equation, because it's going to be n times n. So I'm going to have an n squared to solve. Now we have multiple ways to solve this, but we only can do this if it's equal to 0. The easiest way for me to solve this is by making this equal to 0. So I'm going to expand the left-hand side. I'm going to subtract 42 from both sides. And then I'm going to perform the product sum game. Two numbers that multiply to negative 42 and add to negative 1. Sorry? What are the factors of 42? 1 and 42, 2 and 21, 6 and 7. That's the ones that we have to work with. We have to have, our two numbers are negative 7 and positive 6. I can shortcut this because there's a 1 in front of my n squared term. This works out to be n minus 7 times n plus 6. The only way that that's going to be the case so we have two solutions. N is equal to positive 7, n is equal to negative 6. So we turned from an equation that had factorial notation in it to an equation that was quadratic, second degree, and we get two solutions. However, go back to our definition. Which one of these two numbers does not belong? I'm going to take my negative 6 and try to take the factorial of it. Negative 6 times negative 7 times negative 8 times negative 9. Am I ever going to get the 1? I just keep multiplying for infinity. This is not in the domain. This is not a whole number. So it cannot be a solution to this equation. It is a solution to this equation here, but not all solutions there are going to be solutions up here because we have a positive, or we can't have a negative factor, a negative number factorial. I'm just going to bring up my calculator. Anybody not have access to an 83 or an 84 of some form?
They were actually smart, so we kind of thought this was
So to access the factorial on the button, if I wanted to go 9 factorial, I'm going to have to close this. That. So I want to punch in 9 factorial. I'm going to go 9, and then I'm going to go to the math button, and I'm going to go highlight my probability. And you can see where it shows up under 4. Okay, so please start bringing calculators to class. 9, and then back down to 4. 362,800. As I said, 10 factorial is now in the 36 million range. Sorry, no, 3.6 million range. Okay. It gets big very, very quick. The number that I was talking about before, the 52 factorial, is going to give me scientific notation. Times 10 to the 10, 8 times, so there's 67 zeros following that. And as I said, I think this is the last number that actually shows up on calculators. I'm not sure. And then 70 probably is not going to show up because it's, well, definitely don't want to do random. Okay. So my calculator is limited because it's not going to give me 10 to the 3 digits up top. Okay. So on your calculators, please go ahead and do 10 to the factorial, 11 factorial, 12 factorial, and then 10 factorial over 7 factorial, 3 factorial.
Can I borrow one for today? I left my binders in my dad's truck.
Have to go borrow one.
Who of this is in that? Karsten. Thank you, baby. That's Jason's Patrick. No. We drove in the past. We started last week. And you. Oh, but you were so
Okay, got them all written down. I don't mind about this.
stupid.
What's 11 factorial? Say again, please.
3991680.
39916. I want to read that number as it actually is.
39,960,000.
Thank you.
No, it's not too late.
So what's 12 factorial?
479,000,600.
I missed 1,000.
001. 600.
As you can see, they're getting large very quickly. When you punch this into your calculator, you must remember to put brackets around the denominator. Because if you just punch it in 10 factorial, if I go
I don't know if that's right, but would you get them?
if you do this, what the calculator reads, because it's bed maths, it's going to do this division first and then multiply it by 3 factorial.
Oh.
Okay? But what you want to do is you want to multiply 7 factorial by 3 factorial first and then divide that into 10. So you need your brackets.
I got 1.9.
Okay, I was
Yeah,
right.
you did it right first time. So I just did.
I think you multiply between 10 and 7.
Yeah,
Yeah, because you don't have division. It's going to do 10.
I got a water.
So I gotta do the thingamajigger after every number.
Yes, you do.
I
Okay.
could just throw them out.
But last time. You're just a stick your eye.
If you guys want to go to page 81 here, I'll leave us the rest of this off for tomorrow. 1 ABC. I don't like this one. 3 A and D. 5 A and D. 6 A and D. I'm going to give you about 15 minutes to do that, and then I'll come back and I'll go over it with you. And there will be some homework tonight. You might, if you're working on this, you can finish up the rest of 1, 3, 4, and 5, and 6 also. I go to the washroom. Yes, you may. So you can do all of the stuff because that's going to be the homework. I'm going to go over the ones I have circled in 15 minutes.
Yeah, calculator.
No, I prefer you didn't do it on the calculator.
Just twisted. You do not have the receipt.
$45 in bank.